So hey guys, I'm back again, and this is episode 3 for Backend with Golang from scratch. And in this video, we are going to get started with routing and middleware in Go. So the routing part, I have covered most of it in my previous videos, and you can go ahead and watch it. And I explained all the handlers things and how you can work with basic routing and create your own mux and how to manage multiple mux. I have discussed about it in episode 1 and episode 2, and in this video I am going to build a custom middleware for request logging and response headers, and I would be explaining a bit of a clean routing with Go, which would help you build real production level applications. And these are actually one of the most important things that you are going to encounter, because logging middleware is really essential if you want to monitor your users, like which resource they are trying to access most frequently and what time and everything related to that. And the routing is of course one of the most important parts in backend. So in this video, we are going to create and register custom middleware functions. We will wrap routes with middlewares. We will implement chaining of middlewares, and we will briefly discuss the routing packages. So this is the agenda for today's video. This is my Kitty terminal, and here I have already made my main.go file. You can go ahead and check this out. I have explained it how to get started with Go in my first lecture, so you can go ahead and watch it. In this case, we are going to start it from scratch. We have main file here, and first of all, as always, we will call this package as our main package because this is our main executable code. Then we are going to import a few libraries, and again, big fan of standard libraries, and still we are going to use the very basic thing, which is the format library. We are going to use the log library because we have to log. Log library is the default library. You can go ahead and use other third-party dependencies for this, but I think log itself is more than enough that you will need. In my production level backends also, I mostly consider using it, but in the future videos I will be explaining you more further into how to build all those complicated logs and segregate them. Then we will import the http/log package, which is again one of the important package here because this series is revolving around it, and we obviously have the time dependency with us. So what I'm going to do now is, first I will go ahead and make my main function here. So this is my main function, and here is all the code that is going to be executed. So what we will do first is we will create a mux. I have explained it in the last video. This is http.new serve mux. Again, I have been explaining this new serve mux and went into the documentation in the last video itself. Then we are going to create a few handlers with this first of all. So that let me just get a blueprint of this, like what at the end it should look like. So mux.handle, so we are going to handle this route. I will call it the /route, and we are going to have our HTTP handler here. So I will call it as home handler, and this is perfect. So again, I will go ahead and do another handle so that I can explain more on this. We will have a /about here, and again we will have the about handler. And then we can go ahead and implement our handlers here. So we are going to do home handler here, and we are going to define it. So again, first of all, we will have the http.response writer. So I will write it W. We will have http.response writer in here, and then we will go ahead and do the R, which will be a pointer to http.request. This is the request that is sent by the user, and we are going to extract a few parameters from this. So this is our home handler. What I will do is, just for example, we will just call the format library, and we will do the fprintln, which will be a format print in new line. This is the definition for that. So in the HTTP response writer, I want to say welcome to the home page. As simple as that. Currently everything is saying that you don't have this, you don't have the w dot value of func is not w dot http dot response writer and everything. just keep it aside, no worries about this. We are going to do go ahead and implement that. Again, we are going to do this, make another function called as the about handler as we have promised in the blueprint, and we are going to do a w http dot response writer as always. Here we will write our response, we will have a pointer to our request, and we will get it here, and then we will do the same thing. Now what I'm going to do is just copy this whole thing, go 4 lines down, and just going to paste it in here, and I will go ahead and modify this thing to this is the about page. I will say this is the about page and give exclamation mark, and in here now you know that this is like a function itself. So if I want to call this function and I have defined it in here from line 10 to this 16, so I have declared things here. So for the home handler I have to give the parameters themselves. So what I will do is I have to wrap this inside a handler function. So what I will do is http dot handle func, and I will close these braces in here, and this should make it happen, http dot handle func. So I will see it here, and I will go ahead and close this bracket. So now what we are going to do is just fix this thing here, because we need a handler function, not handle function, just the LSP. Right, perfect. Now again I can just open my thing. Again these errors are just shown because we are not using it currently, but what I will do is do a bit slash comment it down and just save it. I will open my terminal here. You can see ls main.go is here. We'll do go build, and here is our binary. You can go ahead and execute it. Again we haven't executed, it's currently getting compiled into this, but we haven't called it right now. So what I will do is I will say if error is equal to http dot listen and serve as always that we are doing here, and I will run it on 8080, and I will have the mux, my multiplexer, called here, and I will say error is equal to http dot listen and serve. Keep monitoring it, and if error is not equal to nil, it should be nil, because if it's not, then there is an error and we have to get out of this. I will say I can write anything here, like the logic that should be executed in case the listen and serve returns error. So what I will do is, this is a better way to introduce to the log library. So what I will do is go to the log library part and just uncomment it, because now I need it to explain it here. So what I will do is go ahead and do log dot. You have a lot of things that you can do here. You can log dot append, you can log dot do a lot of things here like panic, print, etc. What I am going to do is, since this is an error, I will do a fatal log. So this will mark it as a fatal, and what will we do here is we will put here, like we will say server failed, and I will print out the error in here. So we will go ahead and let me check this out. Why it's saying if error is equal to http dot listen and serve, we have 8080 running, we have mux, and if error is not equal to nil, we have to put a nil in here. Okay, that's fine. So what we will do is, now we will go ahead and do go build. Again, it will be building perfectly. We have the third running. It's getting it might have been running on port 8080. So what I will do is I will do a curl request. I will do a get request to http localhost on port 8080, and I will go to the home path. I will go to the home path. Sorry for that. http / welcome to the home page. Perfect, it's working. Let's just get out of this now. To make this more useful, what I will do is I will also tell you about go.println. So if I want to print anything in the console and I want to write it into a file about this event, I can just go ahead and do println and get into this thing, and I would say starting server on port 8080, three dots. Now, prior to this, we were just going ahead and printing the that we are starting the port on this port, and we were printing it on the log. But it's not a very good practice for that, because in these applications you are going to log everything, and this log is going to go into data warehouses and data lakes and something where it will be processed by other services and potentially used for debugs if you have thousands of microservices running. In this case, log is a better practice. You should go ahead with this. So what we are going to do is, now everything has been implemented. We have the starting server and all those things. This is something that has been covered in the prior lectures. So what I will do is, now it's time to implement a middleware. So we'll go ahead and start implementing our middleware. So what I will do is, first of all, let's have a header middleware just for an example before we go into nested middlewares. Okay, now we are here on my Excalibur, and now I'm going to explain you how middlewares work in API servers, and this is independent of the language that you're using, but in this case we will be talking in terms of Go. So what I will do here is, I will call this as our backend, and this is where all our handlers are present. So what I will do is give here a copy paste and have my client in here. So there will be a communication between the handler and the client. And what is happening here is, I will color it with green, and let's just try to ignore whatever the low level processes and how the network management happens in here. What I will do is, just assume that we have the client, it goes to the multiplexer and everything happens, and at the end it ends up with the handlers. So, and the handlers processes the request and returns it back to the client. This is what usually in the abstracted layers it must look like. So we have a response in here, and request in here, and we have a response in here. So I will call this as a request, and this will be a parallel line, and I will just lift it up and put it here, called as the response in here. Sure, perfectly, this is how it works. Now these handlers are backend logics. Everything that is going to happen in here with the request itself, it will be done by these logics, and it will be returned back to the handlers, and then it will be returned back to the clients. Now what it will happen is, we have the backend logics in here, but imagine we have a logic for every handler, and it is independent of what is happening with the handler. Like, we have a logic that is applied to all the handlers but are independent of what happens with all the handlers. For example, I want to log all the requests. Now here, logging is something that would be done by reading the request and understanding which client it has been sent for, or anything that you can think of, and storing it in a file, and then you can push it into your databases where it will be processed by the systems that you have. But here it is independent of everything, like whatever, if the handler is doing serving data, or it is doing calculations, it doesn't matter. Logging is something which is out of that. One of the main things we have here is authentication. Like, I want that before any user can access, I will call it before any user can access the handlers, they must have the API keys. Sounds fair? We need the API keys. Now we have to check the API keys in every handler, like, okay, request has come, check for the API key. If it presents, all good. If it doesn't present, remove it. But again, why should we implement it to every handler? We can have it in here, we can have it into our logic, which is same into this, and this is where middlewares come in. So what happens is, I will just copy this, paste it in here, and now the response and request will have something in middle of them. Now I will copy it, I will name it as middleware, just expand it a bit, color it with yellow, and then pull it here. So this is what it is going to happen right now. The client will send a request. it will be processed by the middleware, and in the same format it will be returned to the handler, which will be processed here, and it will go back to the client. Now here what happens is the middleware, whatever logic you have, like you have your logging, perfectly fine, you can do it here. Your authentication, you can again do it here. You have rate limiting, one of the important features, you can do it in here. So what happens is you have the client sending requests to the middleware, it logs it, it authenticates it, it implies rate limiting, like it checks for how many times the user has previously put on more requests into that, and then it will like, okay, not many requests have been sent, you can pass it, and it goes to the handler and it goes back to the client. This is how it's going to work. Now there is something called as nesting. There is a concept of nesting into this. So what will be happening here is I will just pull it here because I need more space. I will get this middleware here, and you can have multiple middlewares, like this is middleware 1 and this is middleware 2, and it's perfectly fine. You can have it, let's color it in this color. Now you can have multiple middlewares, and this concept is called as nested middlewares, which we are going to discuss ahead in this video. In this video itself, we are going to focus on logging because authentication and rate limiting are a bit advanced concepts. You need to know how everything works in detail into that, and we are going to cover this in later sections. So yeah, this is how architecture looks like on paper. Here again, I am leaving a lot of things like multiplexing and everything apart in the abstraction level, but on whole and whole, you need to understand this. This is how it is going to work, and when you will see the code, you will yourself understand it. What we are going to do is, first let's make a function called header middleware. This is example that I have chosen for this purpose. Its inputs are, its parameters are, we will call it next because we are going to take that thing and going to pass it to the another function, to the backend logic itself. We are going to first process it and then return it back. So what we'll do is, I will be taking it as handler. And what I will be returning, guess what, http.handler, because I have to return it in the same format as I got. So it's now like a man in the middle. So what I am going to do is, I have to return the whole stuff that I am going to process here. So what I will do is http.handle handler func, and I will have a function in here which I am going to define it. So what I will do is go ahead into the handler func, and I'm going to create a function called as w, and this is your own handler. Now there is a handler inside the middleware that is going to handle the request and going to pass it back to the handler with the main handler that we are going to call. So it will be http.response writer, and you will have r, again pointer, same stuff, request, and done. Then what I'm going to do is just get it out and going to declare it here. So first of all, I will do set the header. This is the backend, this is the middleware logic for me. You can go ahead and do your own logics into here. Here I'm going to set a x custom header to my custom value. Let's say it's Pokemon. Perfect, sounds good. We are going to go down and we will say next dot serve http, and we are going to put in here our handler and our request. So this is the function that returns this http handler. So what is going to happen is we are going to wrap this function into this, and it will first go into this logic itself. It will be returning a handler back which will have this set of instruction implemented, and then you are going to return it. So I will just comment it down here that implement logic, and we will have here as end of middleware logic. Sounds good. We are going to give some space in here. So what you can do here is you can do authentication. You can do authentication in here. How? You will first check for a header called as x-api key-header. this thing. You can define anything into your own place. This is very extensible, but in this case you can have an API key like this, and you can check if API key exists. You should go ahead, and if it doesn't exist, you can return back from it, and you can get out of this logic and never let the user access the handler itself. So okay, this is the part, and now the final part, we have to we just have to go ahead and wrap this thing into this. So what I will do is I will just say header middleware will wrap this function into this, and done. Perfect. Now you're done with implementing the whole thing. Sorry for that. I should get this out of this and put it into HTTP handler itself. I have to get this whole thing into here. Home handler. I will go back in here, and I have to wrap this here actually. So I will do this thing, header middleware. I will do Control Y. Go ahead to the end of the statement and wrap this into this. Again, I'm going to do the same thing. I will first create a closing bracket here, because howsoever I have to do it. Then I will call this function and just remove this. Perfect. Now our middleware has been implemented. So whatever it will do is, whenever a resource is accessed, whenever an endpoint is called, it will first go into the header middleware. Now the header middleware will set the W's custom header to Pokemon, and then it will be going into this. So let's just test it out. First I will go ahead and do go build, and perfect. I will go into here. I will call this part and just execute this third. You can see here the log is working. It's giving you the date, it is giving you the time, and it is being stored into a file. So what I will do is call this thing again, same thing, but now we are going to check which kind of headers we have in here. So you can see here, and you can see that we have a custom header called as a Pokemon. So what did happen in the background? First we got the request, we went into here, we first executed this thing, then went into our home handler, then wrote it down here, and then we returned to the client. So what we are going to do is, okay, now this thing is okay. The next thing that we are going to implement is, we are going to implement logs into our middleware. This is something that we are going to cover here. So and this will teach you about the nested middleware handling. So you can have multiple middlewares with you, and this is very plug and play type. Like you can have multiple middlewares, and if you want to add that middleware into this, it's okay. If you don't want to add some middleware into some request, you can totally get it out. So you can make it modular in this way. So it will call as a logging middleware, and the same thing next, http.handler, and I'm going to return HTTP handler. The same thing, I'm going to go here, I'm going to return http.handler func, and I'm going to have a function in here. It is going to take a handler function, which is like a response writer, which has parameters response writer, and which have a request of http.request. The same thing, same boilerplate code here. Okay. Now what I'm going to do is, first of all, to do a better logging, I will create a function called, I will create a variable called start, and then I will log the time.now. So it will have the current time, what is happening in here, and I will log it with log.printf, and I will be giving some identifiers. I will say %s for string. I have 3 strings to print here in my example. I will print log.method. Perfect. I will have log.request, URI, which URI was it trying to access, and I will have time.since. So what it will do is, since the start, when did this request came? So I'm going to give a start for this, and I will go ahead and do some next and do serve WNR. Perfect, sounds good. And now I'm going to wrap it in here, logging middleware, remove this, go to the end of the line, cover this up, again do the same thing, go here, go to the start of this thing and do logging middleware, and we are going to close this. Sounds good. I will just show you the code. Go ahead, go build. It will be building up. You can do ls, you can do third. You can see here again it has been implemented, and I will call this thing. Now again our custom header is our Pokemon and it's all good, but now you can see in here what thing has been done. What you can see here is you have the get request, you try to access the slash path, and how much time did it take. So it's 125 nanoseconds. So from the time of the starting to the time of the end, this is the time it has been taken. And this is really useful when you are doing your benchmarks, when you will be going with seeing about how much time a resource is taking, how much time a request processing is taking on the backend. You can go ahead and implement this. So yeah, I'm going to go ahead and do on about, enter, and you can see here you access the about thing, and it took 292 nanoseconds. I will do it again. Now it's 334. I will do it again. Now it's 125 again, and do it for a couple of times, and you can see it in here. So different times are been taking here. This comes under the optimization part, which we'll be doing in the future itself, not now. So yeah, what we are going to do is then we are going to write this again, and now we are going to conclude this. This is how the middleware part works into this, and middlewares are really essential when you're working with monetizing your API and you're trying to do authentications, logging, and all those stuff. From my personal experience, since I'm writing production level backends, I use this for these two purposes. First of all, it's logging, which user is trying to access what thing based on his API key. I go ahead and monitor his uses, and I know that how much quota he has for the request to be made, and this way I make sure that I count how many requests he's making and using resources in a fair way, and he is getting what he is paying for. And for other thing, I use it for logging. Logging is one of the stuff, and the authentication part, I make sure that all my APIs are authenticated and only legitimate users are getting access to this, and I know my user if he's spamming or if he's doing anything malicious into there. I know about it, and whenever I deploy it, I see a lot of bots and other things doing scans on my this thing, trying to break into my security. Hopefully they don't. But this is how I monitor everything, and all the logs go into my data storage where they are getting analyzed by machine learning systems, and they see which users are accessing which resources, which content they are interested in, and they go ahead and do it. They go ahead and create his recommendation feeds, tags into there, and I'm able to feed the right content for the right user on my front end. So this is really essential for the real industry, and in the future I'm going to hopefully make some videos on building these machine learning systems, designing these machine learning systems. So yeah, this was this video, and hopefully you like it. Bye bye.